Okay, so in this section, 4.1, we are talking about maximum and minimum values of a function. And these are also referred to as extrema. Or extreme points. Oh, let me rewrite this. And so these are the highest and lowest values of our function. There are two different types. So we could have absolute extrema or local extrema. And so we could have either absolute max or absolute min, or a local max or a local min. And so we get four different types of extrema. And so each of these is defined here. So let's just go over the definition. So what this says is that, C is a number in the domain, and f of c, so meaning the value of the function, is the absolute max if it is greater than or equal to all other values of the function in the domain, right? So that's what this part is saying. And then similarly, f of c is the absolute min if it is less than or equal to all other values of the function in the domain, right? So, so those are our absolute extrema, and then we have our definitions of local extrema. And so we say that f of c is a local max if there exists an interval containing c such that within that interval it is the highest value, right? So that's what this is saying. And then a local min, the same idea. So if we have an interval and inside of that interval it is the lowest value, okay? And so this should make these definitions should make more sense once we look at this example. So I do have some things to note, but we'll come back to that because I want to first look at the example. Okay, so here we have this function and its domain is -1 to 4, and so this is the entire graph of the function, and it stops right here and also there, so at these 2 points. Okay, so we want to find all the extrema, and so let's start with the absolute max. Now the absolute max is the highest value that the function attains, and so we can see that the highest point on the graph is this right here, and the y value, or the value of the function at that point, is 37. So that's the y coordinate of that point because it's labeled right there. So the absolute max is going to be 37, right? And this occurs at x equals -1. So the max is the value that the function takes on, and its location we refer to with the x coordinate, right? And similarly, we have the absolute min, and this is going to be the lowest value that the function attains, and so we see that that is this point right here. The y coordinate is -27, so the absolute min is -27, and this occurs when x equals 3. Okay. You don't, when you're answering this type of question, you actually don't need to include this part, but it's nice to include it just to be clear. So that is our absolute extrema, and then our local extrema. Let's start with local max. So a local max occurs when it's the highest point compared to nearby points. And so if we're looking at this point right here on the graph, see that it's the top of this sort of hill. It's at the very top, we have a highest value compared to what's going on around it. It's not the highest value overall, but it is when we just focus our attention around that point. Okay, so we have a local max, and it occurs at x equals 1, and it is 5, right? So the value of the function there. And we have also local minima. So we have one so we'll start with this one. So this one was an absolute min. It is also a local min, right? So we have a local min that's at x equals 3. So we have one local min, and the value is negative 27 there, and another local min that occurs right here at 0, 0. So that's when x equals 0 and the min is 0, right? Okay, so those are all of our extrema. One thing to note is that this is an absolute max up here. It was the value at the endpoint, but it is not a local max. So since we can't fit an open interval around this point to compare it to the points nearby, it is not a local max. So usually when you run into this, it's because it's at the end point of an interval. So this point here is an absolute max, but not local. Yeah, get rid of that too. Okay, and this point here was both, maybe I'll write this in a different color. This point here was both an absolute min and a local min. So it can occur that you have both, or you could have an absolute max or min, but not local. Okay. Now, so let's go ahead and talk about some things having to do with this. So first of all, we say that so you can see in these definitions, it's always f of c. So we say that the value of the function is the max or min, right? Not the x value, we use the y value, right? So so not c, or let's write x equals c to make it more clear what that is. Okay, but we can say that that max or min occurs at x equals c, right? So that's what we're writing down here in our example. Okay, another thing is that a function can have at most one absolute max and one absolute min. Okay, but it could occur at more than one point. Okay, and so one example of that is the function sine of x. So remember that it just keeps oscillating. That's not quite right, but so it bounces up and down, right, between -1 and 1. So the absolute maximum value that this function attains is 1, but it happens actually infinitely often because sine just keeps bouncing up and down between -1 and 1. But we still say that it only has one absolute max because it is really that maximum value, right? Okay, and I didn't quite leave myself enough room, so I'm gonna cheat and move this up. Okay, now I'm gonna squeeze this in here. It's possible that a function might not have an absolute max or min. Absolute max or min. In fact, if we look at the function 1 over x, which looks like this, right? So it has a vertical asymptote at 0 and also horizontal asymptote at 0. So this function actually has no extrema. There are no absolute max, no absolute min, no local max, no local min. So this function has no extrema. So this can happen. But of course we'll probably have mostly examples that do have maxes and mins. Okay, so I think that's all for this video, and then we will talk about the extreme value theorem in the next video.